Good morning, Over LC Middle School 7th graders. This is Mr. Woolley, and we are going to start with Lesson 2 today on your Eureka Math or Engage NY packet, whatever you want to call it. We're going to continue with yesterday's concept about working with ratios and rates, and now we're going to determine if they form proportional relationships or not. So let's take a look at our first example. It says a new self-serve frozen yogurt store opened this summer. It sells its yogurt at a price based upon the total weight of the yogurt and its toppings in a dish. Each member of Isabel's family weighed his dish, and this is what they found. Determine if the cost is proportional to the weight. All right, so we have our table here of information. It's got the weight and how much it would cost. So 10 ounce would cost $4 and so on. What I want to do is notice how they phrase it. If the cost is proportional to the weight. So I'm going to take the cost and divide it by the weight, which is normally how we'd set up a rate anyways, with money first. So take 5 divided by 12.5, I get 0.4 on your calculator, but obviously since it's money, I have to go 2 places past and put a 0 there, so 0.40 cents per ounce. And I keep doing the same thing. I take the money divided by the ounces, and all the way through, I kept getting 40 cents per ounce. So since it's the same consistent rate, I'd say the cost is proportional to the weight. All right. Example 2. In the back of a recipe book, a diagram provides an easy conversion to use while cooking. Obviously, 0 cups will be 0 ounces of something, but half a cup makes 4 ounces. 1 cup makes 8 ounces, and so on. We're going to figure out if these are going to be proportional to the cups. Well, if I take 4 and divide it by a half, or 0.5, I guess I could say, I get 8 ounces per cup. 8 divided by 1 gives me 8 ounces per cup. 12 divided by 1.5, or 1.5, gives me 8 ounces per cup, and 16 divided by 2 gives me 8 ounces per cup. So I'm going to take one value and divide it by the other, a y value usually, divided by an x value, and we'll go ahead and divide those. In this case, since they're all the same, I'd say the ounces are proportional to the cups. All right, we shift over to another problem. Here's exercise 1. It says, during Jose's physical education class today, students visited activity stations. Next to each station was a chart depicting how many calories on average we burned by completing the activity. So we broke it down into 4 situations. So you spend a minute, you burn 11 calories, and so on, A, B, C, and D. And they want to know, is the number of calories burned proportional to the time? How do you know? Well, try to figure out how many calories per minute we are burning. All right? So take our first scenario. 11 calories for 1 minute, so divide those, you get 11 calories per minute. 22 calories get burned in 2 minutes, I divide that and I get 11. As you can see, throughout the whole process here, I get 11 calories per minute. So yes, while jumping rope, you'll always burn 11 calories per minute, and it is proportional. And if he jumped rope for 65 minutes, or 6.5 minutes, sorry, how many calories would be expected to burn? Well, if we are burning 11 calories per minute, when he does this for 6.5 minutes, all I do is take 11 times 6.5, and it tells me that over the course of those 6.5 minutes, it burns 71.5 calories. All right, so next up, we'll take a look at some more examples on our next page here. All right, this time, Alex spent the summer helping out his family's business. He was hoping to earn enough money to buy the new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? Well, to determine if he'll have enough money, he decided to make a table. He entered his total money earned at the end of week 1 and entered his total money earned at the end of week 4. All right, so I use those special combinations. How much you made after 1 week, 28 divided by 1 is $28 per week. I double check what else they gave me. If I took 112 divided by 4, I'd also get $28 per week. So we do know that $28 per week is going to apply to each week. So obviously, if he doesn't work any weeks, he gets 0 money. But remember, he gets $28 for 1 week. So 28 times 2 is 56. 28 times 3 is 84. 28 times 4 is the 112. And we keep kind of multiplying that out to finish our table. So anyways, he wants to know if he's going to have enough money by the end of the summer there. Well, he wants to buy a video game system for $220. And by the end of the summer, apparently, he's going to have 224. So I would say, yes, he is going to have enough money. All right? So, and they want to know, are Alex's total earnings proportional to the number of weeks he worked? How do you know? Well, yeah, he makes $28 a week, and that's how we figured out the table. So, yes, it has to be proportional, because otherwise I wouldn't be able to fill the table without knowing that he makes $28 a week. All right. Let's look at just a couple examples here that are on page 7. It says a cran apple juice blend is mixed in a ratio of cranberry to apple from 3 to 5. So complete the table to show different amounts that are proportional. Well, the amount of cranberry to apple is 3 to 5. So cranberry 3, apple 5. Cranberry came first in the combination here, so the 3 had to go with the cranberry. And then what I did was I just kind of doubled the original ratio. Well, 3 to 5, I times them by 2, I get 6 to 10. And I could take that original ratio and triple it, times it by 3. And I get 3 times 3 is 9, 5 times 3 is 15. So you can take that original ratio, double it, triple it, quadruple it, however you need to continue on with the table. So, and of course, these are proportional because I'm using the same rate throughout the problem. All right, number 2. John's filling up a bathtub that's 18 inches deep. He notices it takes 2 minutes to fill the tub with 3 inches of water. He estimates it will take 10 more minutes for the water to reach the top of the tub if it continues at the same rate. Is he correct? Well, I want to set up a table to help me here, and I'll start with the original information. The original rate was he was getting 3 inches of water in the tub for every 2 minutes. All right? So I take that ratio, and then I double it. Well, so from 2 minutes, if I double it, I get 4 minutes, which means 3 inches of water doubled, now becomes 6. And every time I add 2 minutes, I'm going to add 3 more inches of water. So I kept on going throughout the table, 2 more minutes, 2 more minutes, 2 more minutes, and then kept adding 3 inches of water at a time until I got to the end here. And as you can see, in 12 minutes, I'll have 18 inches of water. Now, why did I stop at the 12-minute mark? Well, he had already filled the tub up for 2 minutes, and then he says it's going to take 10 more minutes to fill the tub. So 2 minutes plus 10 minutes gives me 12 minutes, so I stopped that table. And at that 12-minute mark that I figured out, there will actually be 18 inches of water, and that's how deep the tub is, it said from the original problem. So yes, he is correct. All right, so that's kind of some concepts that we have, and there's some practice problems for you to try in Schoology now. I believe there's 4 of them, so you can go ahead and give those a try. Thank you.